1. Introduction. The theory of production explains how inputs, like labor, machines, and raw materials, are used to produce outputs, finished goods and services. The main focus is on how efficiently production happens, rather than just looking at costs. 2. Meaning and definition of production. Production means converting natural resources into useful products that satisfy human needs. It is an organized process where raw materials are turned into finished goods or services. Production creates utility, usefulness, in 3 ways. 1. Form utility, changing the shape or nature of a product, e.g. wood into furniture. 2. Place utility, making products available where they are needed, e.g. transporting goods. 3. Time utility, storing products for future use, e.g. cold storage for fruits. Definitions: James Bates and J.R. Parkinson. Production is an organized activity of transforming resources into goods and services to satisfy demand. Production is any activity aimed at satisfying people's wants through exchange. Short trick to remember: form utility. P. Place utility. Time utility. This way, you can easily recall the 3 types of utility in production. Factors of production. The factors of production are the resources needed to produce goods and services. They are 1. Land, 2. Labor, 3. Capital, 4. Entrepreneur. Land. Meaning, land includes all natural resources like soil, water, air, and minerals. It is not just the surface of the earth. Nature of land. Primary factor. Every business needs a location, own or rented. Passive factor. Land alone is useless. Investment and labor are needed to make it productive. Free gift of nature. We cannot create land or increase its natural resources. Value depends on location. Immobile. Land cannot be moved from one place to another. Some areas are fertile, while others are barren. Example: a factory needs land to build its premises, but the land itself won't produce anything unless workers and machines are used. 2. Labor. Meaning, labor is human effort, mental or physical, used to produce goods and services. It must be done for economic benefit, earning money. Division of labor. Work is divided among workers so that each person does a specific task. Repeating the same task makes a worker more skilled and efficient, increases productivity, and reduces mistakes. Example: in a car factory, one worker fits tires, another paints, and another checks quality. This specialization makes production faster. Capital. Meaning, capital is man-made wealth used for further production. It includes money, machinery, buildings, and tools. Types: stock concept, initial investment for business setup. Flow concept, income generated from the business. Capital is different from land and labor because it is created by humans. Example: a bakery owner buys an oven, capital, to bake cakes. The oven helps produce more cakes and generate more income. 4. Entrepreneur. Meaning, the entrepreneur is the person who combines land, labor, and capital to start a business. He takes risks in the business. He makes decisions and manages the production process. Also called an organizer, manager, or risk taker. Example: Elon Musk, Tesla, and Jeff Bezos, Amazon, are entrepreneurs who started businesses by using resources wisely. Short trick to remember: LLCE, land, L, labor, C, capital, E, entrepreneur. This makes it easy to recall the 4 factors of production. Nature of factors of production. These are the main characteristics of the factors of production. Derived demand. Factors like land, labor, and capital are not directly demanded by consumers. Their demand depends on the demand for the final product. Example: if demand for cars increases, demand for steel, capital, workers, labor, and factory space, land, also increases. Both mobile and immobile factors. Immobile: land is fixed and cannot be moved. Mobile: labor, entrepreneurs, and capital can move to different locations. Example: a factory can shift workers and money to a new location, but the land remains in its place. Consumers never demand factors directly. Consumers only demand finished goods and services. Producers need factors like land, labor, and capital to create those goods. Primary inputs: land, labor, capital, essential for production. Secondary inputs. Raw materials, used in production but not factors of production. Example, people buy bread, not flour, wheat farms, or bakery equipment, but producers need these to make bread. Both active and passive factors. Active, labor and entrepreneur. They make decisions and take action. Passive, land and capital. They are used but do not take action. Example, a business owner, entrepreneur, and workers, labor, actively run a factory while machines, capital, and land remain passive. 5. Combined demand. No single factor can produce goods alone. Production happens when all factors work together. Example, to produce a mobile phone, you need land, factory space, labor, workers, machines, and money, entrepreneur, decision maker. 6. Free gift of nature. Land is a natural gift, but other factors, labor, capital, entrepreneur, are created by humans. Example, soil, forests, and minerals exist naturally, but money, capital, and business skills, entrepreneurship, come from human efforts. Short trick to remember, DC camp. Derived demand, combined demand. Consumers don't demand factors. A, active and passive, mobile and immobile. Free gift of nature, nature. This will help you recall all key points easily. Production function. The production function explains the relationship between inputs, resources used, and outputs, goods, services produced. One simple explanation. It shows how much output can be made using different amounts of inputs. Inputs equals land, labor, capital, entrepreneur. Outputs equals goods and services. It also considers the level of technology used in production. Formula Q equals F, x1, x2, x3, xn. Q equals quantity of output, x1, x2, x3, xn equals different inputs used. 2. Example for easy understanding. Think of a bakery that makes cakes. Land, shop space. Labor, bakers. Capital, oven, ingredients, money. Entrepreneur, bakery owner. If the bakery increases labor and better ovens, it can make more cakes. This change in inputs affects the output. 3 key points to remember. Production function equals input-output relationship. More better inputs, more output. Technology level affects production efficiency. Least possible inputs, maximum output. Short trick to remember, ILOC. Inputs, land, labor, capital, entrepreneur. Least possible inputs for max output. O, output, goods and services. Q, quantity produced, Q equals X. This trick will help you recall the concept quickly. Function. These are the basic conditions that must be true for the production function to work properly. 1. Simple explanation. The production function makes some assumptions about inputs, resources, and outputs, goods, services, to make the calculations easier and predictable. Key assumptions and examples. Inputs and outputs are perfectly divisible. You can split them into smaller parts. Example, a bakery can produce half a cake if needed. One factor may not always replace another. Labor can't always replace capital, machines, and vice versa. Example, a factory can't replace all workers with machines completely. Technology remains the same. No new inventions or upgrades during the production period. Example, if a textile mill uses old machines, it will not suddenly start using new, automated ones. Some factors are fixed in the short run. Certain resources can't be changed quickly. Example, a shop can't expand its physical space overnight, but it can hire more workers. Production function applies to a specific time period. The relationship between input and output is studied for a particular time. Example, a company producing 500 shoes per month follows a production function for that time frame. 3 short trick to remember. DTSFP. Divisible inputs and outputs. T. Technology is constant. S. Substitution not always possible. Fixed factors in short run. P. Production is time-based. Remember DTSFP as a simple way to recall these assumptions quickly. Importance of production function in managerial decision-making. Managers use the production function to make better decisions about production, costs, and efficiency. Simple explanation. Production function helps managers decide how to use resources efficiently to get the best output at the lowest cost. Key applications and examples. Short-term decisions. Helps in deciding how to use inputs efficiently to get maximum output. Example, a factory must decide which machines to use to produce 1,000 chairs with minimum cost. Long-term decisions. Helps in deciding whether to increase or decrease production based on returns to scale. Example, if a company sees higher profits by increasing production, it should expand. Cost control. Helps managers find the best mix of inputs to minimize costs. Example, a car company must decide how many workers and robots to use for production. Substitution of inputs. If one resource becomes expensive, managers can replace it with another. Example, if labor costs rise, a company may invest in automation to reduce expenses. Efficient resource allocation helps in properly distributing resources for better productivity. Example, a restaurant must decide how many chefs and waiters are needed for smooth operations. Scale. Short-term decisions, best use of inputs. C. Cost control, minimize expenses. A. Allocation of resources, proper distribution. L. Long-term decisions, increase-decrease production. E. Exchange of inputs, substituting resources. Remember scale to recall the importance of production function in decision-making. Types of production function. Production functions describe how inputs, land, labor, capital, are converted into output, goods, services. They are classified into short-run and long-run production functions. 1. Short-run production function. Only some inputs can change, while others remain fixed. Linear function. Simple, output increases at a constant rate with input. Example, one worker produces 10 units, 2 workers produce 20 units. Quadratic production function, output increases but at a decreasing rate after a certain point. Example, a company hires more workers but overcrowding reduces efficiency. Cubic production function, output first increases fast, slows down, and then decreases after a limit. Example, a factory increases machines, but too many cause inefficiency. Power function, output depends on inputs raised to a power. Example, if labor is doubled, output may increase 1.5 times, not exactly double. 2. Long-run production function. All inputs can change, allowing firms to expand or contract. Cobb-Douglas production function, most common, shows how output depends on labor and capital. Example, output equals A labor, B, capital C. Constant elasticity of substitution, CES. Function, inputs can be substituted at a fixed rate. Example, robots replace workers, but production stays the same. VES, variable elasticity of substitution function. Input substitution is flexible and changes over time. Example, a factory shifts from manual work to AI-based machines. Fixed proportion production function. Inputs must be used in a fixed ratio for production. Example, to make one car, exactly 4 tires and 1 engine are needed. Linear programming production function, used in optimization problems to maximize profit and minimize cost. Example, a company calculates how much raw material is needed to minimize waste. Chat 3, short trick to remember. LQCP CCFVL. Linear. Q, quadratic. C, cubic. PED. C, Cobb-Douglas. CESF, fixed proportion. VIVLIS, linear programming. Remember LQCP CCFVL to recall the types of production functions. Short-run production function. In the short run, some inputs, like labor, can change, while others, like machines or factory size, remain fixed. The production function in this case is categorized into 4 types. And 1, linear production function. Formula, y equals a plus bx, meaning output increases at a constant rate when input increases. Example, a worker produces 10 units, 2 workers produce 20 units, 3 workers produce 30 units, straight line growth. Key formulae. Average product AP, yx equals a by x plus b, output per unit of input, marginal product, MP, delta y delta x equals b, extra output from one extra unit of input. 2. Quadratic production function. Formula, y equals a plus bx minus cx squared. Meaning output first increases but then slows down due to diminishing returns. Example, a restaurant hires more waiters. Initially, service improves, but after a point, overcrowding slows down efficiency. Key variables. Y, total output. X, total input. A, B, C. Constants determined by data analysis. Cubic production function. Formula, y equals a plus bx plus cx squared, dx who. Meaning, output increases rapidly at first, then slows down, and finally decreases. Example, a factory buys more machines. Initially, production increases, but too many machines create congestion, reducing efficiency. Key properties. I, marginal productivity, rises first, then falls. I, elasticity of production keeps changing along the curve. E-RI, in later stages, marginal productivity drops quickly. 4. Power function. Formula, y equals axb, meaning out depends on inputs raised to a power, not necessarily linear. Example, a business doubles its workers, but output does not exactly double, it increases at a different rate. 3. Short trick to remember. LQCP, linear, Q quadratic, C, cubic. Remember LQCP to recall the 4 types of short-run production functions. Run production function. In the long run, all inputs, labor, machines, factory size, etc., can be changed. The long-run production function includes different models explaining how inputs and outputs are related. Cobb-Douglas production function. Formula Q equals A, L to K-thar, meaning output Q depends on labor, L and capital K, with A representing technological progress. Example, A factory increases both workers and machines, leading to higher production. Key points. If A plus beta of 1, increasing returns to scale, output grows faster than inputs. If A plus beta equals 1, constant returns to scale, output grows at the same rate as inputs. If A plus beta 1, decreasing returns to scale, output grows slower than inputs. Properties. Constant returns to scale. Elasticity of substitution equals 1, inputs can be easily replaced. If one input is 0, output is also 0. Criticism. Ignores factors like technology and natural resources, assumes perfect competition, which is unrealistic. 2. Constant elasticity of substitution CES production function. Formula Q equals A av k plus 1 thed. Meaning, this function allows different levels of substitution between capital and labor. Example, a company can replace workers with robots without impacting production too much. Key points. The function includes 3 key variables. A, efficiency constraint, represents technology and organization. A, capital intensity factor, shows how much output depends on capital. Theta, substitution constraint, defines how easily labor and capital can replace each other. Advantage, more flexible than Cobb-Douglas as it allows different levels of substitution. 3. Variable elasticity of substitution vs. production function. Meaning, similar to CES, but the substitution factor A is not fixed, meaning elasticity changes over time. Example, a company gradually shifts from labor-intensive to machine-intensive production. Key properties, follows neoclassical production rules. More flexible than CES, as it does not require a fixed substitution value. 4. Fixed proportion Leontief production function. Meaning, inputs must be used in fixed ratios, meaning no substitution is possible. Example, a car needs 4 tires. Even if the company has 10 extra tires, they cannot increase car production without more engines. Key points. If one input N is in excess, it remains unused. If one input is missing, production stops completely. Formula, Q equals min K A L B, where capital and labor, A and B equals constants showing required proportion. 5. Linear programming production function. Meaning, optimizes output based on limited resources. Example, a bakery must decide how many cakes and pastries to produce based on available flour, sugar, and ovens. Formula: maximize x equals a1 x1 plus a2 x2 plus a and xn minus where maximizing x1 x2 xn2 xn equals different outputs a1 a2 and constants showing resource use. Cobb-Douglas. CES, constant elasticity substitution. VES, variable elasticity substitution. Fixed proportion, Leontief. Linear programming. Remember CCVFL to recall the 5 types of long-run production functions. Estimation of production function, simple explanation. The production function tells us how inputs, like labor and capital, are used to produce output. We use mathematical equations to estimate the output based on available resources. Let's understand this with 3 examples. Example 1, market demand for Rohan's cards. Given equations, friend 1, Q equals 60 minus 2p. Friend 2, Q2 equals 45, 1.5p. Friend 3, Q3 equals 75 minus 2.5p. Total market demand, QP equals Q1 plus Q3 equals 60 minus 2p plus 45 minus 1.5p plus 75 and 2.5p equals 180 minus 6p. This means that for every 1 decrease in price, demand increases by 6 cards. To sell all 120 cards, we set Q equals 120. 120 equals 180 minus 6p. Solving for p, we get p equals 10. Conclusion. If Rohan wants to sell all his cards, he should set the price at 10 per card. Example 2, finding maximum output. Production function. Q equals 25L 1/2, K square 1/2, given 90L equals 100 labor, K equals 100 Na capital. Substituting values, Q equals 25 and 100, Q equals 25 pen 10 equals 2,500 units. Conclusion. With 100 labor units and 100 capital units, the firm can produce 2,500 units of output. Example 3. Impact of changing inputs. Given production function, QC equals 5K plus 10 in time. When K equals 2 and L equals 4, QC equals 5, 2 plus 10, 4, QC equals 10 plus 40 is 50 units. When both inputs are doubled, K equals 4, L equals 8, QC equals 5, 4 plus 10, 8. Q// equal 20 plus 80 equals 100 units. Conclusion. If we double the labor and capital, the output also doubles from 50 to 100 units. Short trick to remember, word method, key points. Demand, output, price, doubling. Word DOPD. D equals demand equation, example 1. O equals output calculation, example 2. P equals price determination, example 1. D equals doubling inputs effect, example 3. This trick will help you recall the concepts quickly during exams. Limitations of production function, simple explanation. The production function helps in understanding how inputs, labor, capital, are used to produce output. However, it has some limitations in real-world applications. Limitations. 1. Limited to 2 inputs and 1 output. It mostly considers only 2 inputs, like labor and capital, and 1 output, but real businesses use many inputs, like raw materials, energy, etc. 2. Assumes smooth and continuous production. In theory, production happens in a smooth flow, but in reality, unexpected interruptions, like machine breakdowns, worker strikes, can occur. 3. Technology is assumed constant. The production function assumes no technological changes, but in real life, technology keeps improving, making production more efficient. 4. Perfect competition assumption. It is based on a perfectly competitive market, but in reality, most markets have some level of monopoly, oligopoly, or government intervention. 5. Labor is assumed to be homogeneous. It considers all workers as equal in skill and productivity, but in reality, workers have different skills, experience, and efficiency levels. Short trick to remember, key points. Inputs, smooth, technology, competition, labor. Word ISTCL, I equals inputs limited, only 2 inputs. S equals smooth curve assumption, not real. T equals technology remains same, unrealistic. C equals competition, perfect competition is rare. L equals labor assumed equal, but different in real life. This trick ISTCL will help you recall the limitations quickly during exams. Laws of production, simple explanation. The laws of production explain how changes in inputs, like labor, capital, land, affect the output of a business. There are 3 main ways to study this. Law of variable proportions, 1 variable input. Some inputs, like land, machines, are fixed, while other inputs, like labor, raw materials, change. This law studies how output changes when only one input is varied. Example: if a factory has a fixed number of machines, but increases workers, production increases at first, but later slows down. Isoquant analysis, two variable inputs. Here, two inputs, e.g. labor and capital, change together to produce different output levels. The goal is to find the best combination of inputs to maximize output efficiently. Example: a company can use more machines and fewer workers, or more workers and fewer machines to produce the same goods. 3 returns to scale, all inputs variable. In this case, all inputs change together, e.g. doubling both workers and machines. It studies how much output increases when all factors of production are increased. Example: if a factory doubles its size, machines, workers, land, will output double, more than double, or less than double? Short trick to remember word method. Key points, variable, isoquant, returns. Word equal V equals variable proportions, one input changes. I equals isoquant, two inputs change. Returns to scale, all inputs change. This VR trick will help you quickly recall the 3 laws during exams. Law of variable proportions, simple explanation. This law explains how our output changes when only one input, e.g. labor, is increased, while other inputs, e.g. machines, land, remain fixed. Key idea: in the short run, some inputs cannot be changed, like machines, land. Only one input, like labor, changes to see how it affects total production. Initially, adding more of the variable input increases output, but after a point, output starts decreasing. Example: imagine a pizza shop with one oven, fixed input, and workers, variable input. 1. First worker makes pizzas efficiently. Second worker increases production, teamwork helps. 3. Third worker, production increases but space is limited. 4. Fourth worker, workers start getting in each other's way. 5. Fifth worker, too many people, production slows down. Conclusion: adding more workers initially helps, but after a limit, too many workers reduce efficiency. Definitions, key points to remember. F. Benha, increasing one input increases output, but after a point, output starts decreasing. G.J. Stigler, when one input keeps increasing while others stay fixed, the additional output, marginal product, will eventually decrease. Short trick to remember. Key points: variable, fixed, diminish, word VFD, V equals variable input changes. F equals fixed input does not change. D is diminishing returns, output decreases after a point. This VF trick will help you quickly recall the law in exams. Assumptions of the law of variable proportions, simple explanation. This law works only under certain conditions. These conditions, assumptions, ensure that we get clear results when studying how output changes with one variable input. Key assumption: when one input is variable, others are fixed. Only one factor, like labor, changes, while others, like land, machines, stay the same. 2. All variable inputs are identical. Every unit of the variable input is the same in quality, e.g., all workers have the same skill. Technology remains unchanged. No new technology is introduced during production. 4. Input proportions can change. We can change how much of each input we use. 5. Applies only in the short run. In the long run, all inputs can be changed. So this law applies only in the short run. 6. Products are measured in physical units. We measure output in kilos, tons, liters, etc., not in money terms. Example: imagine a farm where land is fixed, constant. Workers, labor are variable, changing. If more workers are added, output will first increase and then decrease due to crowding. This follows the law of variable proportions. But only if technology is the same, workers are equally skilled, and land is not expanded. Short trick to remember, word method, key points, variable, fixed, same, short, measure. Word equal VFSSM, V variable input changes, F equals fixed inputs, constant, S equals same technology, S equals short run, M equals measured in physical units. This VFSSM trick will help you quickly recall the assumptions in exams. Total, average, and marginal product, simple explanation. These three terms help us understand how production changes when we add more inputs, like labor. Key terms. 1. Total product, TP. Total output produced using all inputs. Example, if 5 workers produce 520 units. 2. Average product, AP. Output per unit of variable input, labor. Formula, AP equals TP when know of workers. Example, if TP equals 520 and labor equals 5, then how to AP equals 520 but 5 equals 104. 3. Marginal product, MP. Extra output from adding one more worker. Formula, MP equals change in TP and part change in labor. Example, if TP increases from 430 to 520, MP and 530 equals 90. Relationship between TAP and MP. At first, TP, AP, and MP increase, more workers, more production. MP increases faster than AP because each new worker adds more output. When AP is at its maximum, MP equals AP. This is the most efficient point. After a point, MP decreases faster than AP. Too many workers cause inefficiency. When MP is negative, TP starts decreasing. Too many workers reduce productivity. Example, factory producing mobile phones, 1 worker, 100 phones, 2 workers, 210 phones, MP equal 110, 3 workers, 330 phones, MP 120, highest MP, 6 workers, 600 phones, MP starts falling, MP equal 80, 10 workers, 760 phones, MP equals 10, nearly no improvement. 11 workers, 740 phones, MP equal minus 20, production decreases. Hash a short trick to remember, word method, key points, total, average, marginal, increase, decrease. Word TAMID, T equal total product, TP, A equal average product, AP, M marginal product, MP, I equals increase, MP, AP at first, D equal decrease, MP, AP later. This TAMID trick will help you recall the concepts in exams quickly. Law of diminishing marginal productivity, simple explanation. This law states that as we keep adding more of a variable input, like labor, while keeping other inputs constant, like land or machinery, the extra output, marginal product, first increases, then decreases, and finally becomes negative. At first, adding more workers increases production efficiently. After a point, adding more workers leads to less extra output per worker. Eventually, adding more workers reduces total output. Example, restaurant kitchen. Imagine a restaurant kitchen with 1 stove, fixed input, and chefs, variable input. 1 chef makes 10 pizzas. More chefs, more output. 2 chefs makes 25 pizzas. Better teamwork, more output. 3 chefs makes 40 pizzas. Best efficiency. 4 chefs makes 45 pizzas. 5 chefs makes 43 pizzas. Too many chefs. 6 chefs makes 38 pizzas. Some chefs have nothing to do. After a certain point, adding more chefs reduces productivity. Graph understanding MP and AP curves. MP curve, marginal product, rises, reaches peak, falls. AP curve, average product, follows MP but declines slower. When MP is negative, TP, total product, starts decreasing. Why does this happen? Reasons for decline. 1. Fixed inputs get overloaded. Limited space, machines or land. 2. Optimal point exists. Best worker to resource ratio. 3. Overcrowding reduces efficiency. Too many workers cause confusion. 4. Imbalance in input proportion. More workers but same resources equals decline. Short trick to remember word method. Key points. Fixed, optimal, overload, decline. These stages of the law of variable proportions. Simple explanation. This law explains how production changes when we keep increasing a variable factor like labor, while keeping other factors like land or machinery fixed. It happens in 3 stages. Stage 1. Increasing returns, high efficiency. Total product TP increases rapidly. Marginal product MP increases. Average product AP increases. Why? Workers utilize fixed resources better. Better teamwork and specialization. Example, In a restaurant, when you add the first few chefs, production increases rapidly as they start using the kitchen efficiently. Stage 2, diminishing returns, optimal efficiency. TP still increases, but slowly. MP starts decreasing. AP reaches maximum, then falls. Why? The kitchen is getting crowded. Limited ovens and workspace. Reduce efficiency. Example: adding a fifth or sixth chef still increases pizza production, but at a slower rate. Stage 3, negative returns, inefficiency. TP starts decreasing. MP becomes negative. AP keeps falling. Why? Too many workers, not enough space or resources. Workers disturb each other, reducing productivity. Example: adding 10 plus chefs in a small kitchen makes them bump into each other, slowing production. Short trick to remember. Key points: increasing, optimal, negative. Word ion, easy to remember like energy ion. I equals increasing returns, stage 1. O equals optimal returns, stage 2. N equals negative returns, stage 3. Now, if you remember ion, you'll recall the 3 stages of the law of variable proportions easily in exams. Of increasing returns. Simple explanation. This law explains what happens when we increase a variable factor, like labor, while keeping fixed factors, like land or machinery, constant. Total product, TP, increases rapidly. Marginal product, MP, increases first, then slows down. Average product, AP, keeps increasing. At the end of this stage, AP reaches its highest point, while MP starts decreasing. Why does increasing returns happen? Key reasons. 1. Underutilization of fixed factors. Fixed resources, like machines, land, aren't fully used in the beginning. Adding more workers makes better use of them, increasing output. 2. Indivisibility of fixed factors. Some resources cannot be divided into smaller parts, e.g., a factory setup. Even if production is low, some machines still need to run at full capacity. As more workers join, machines work more efficiently. 3. Specialization and division of labor. Workers focus on specific tasks, becoming faster and more skilled at their jobs. Example: in a car factory, one worker paints, another assembles, another checks quality. 4. Saving of time and resources, Mrs. Robinson's view. Less training and time waste due to specialization. Tools and machines are used better, increasing efficiency. Short trick to remember, word method. Key points: underutilization, indivisibility, specialization, saving. Word equals UISS. Sounds like use, to remind you that resources are used efficiently in this stage. U equals underutilization of fixed factors, equals indivisibility of fixed factors, equals specialization and division of labor, saving of time and resources. If you remember UISS, USE, you'll recall the law of increasing returns easily in exams. Law of diminishing returns, simple explanation. This law states that as we keep adding more variable inputs, like labor, to fixed inputs, like land or machinery, the additional output, marginal product, will start decreasing after a certain point. Total product increases, but at a slower rate. Marginal product, MP, and average product, AP, decreasing. At the end of this stage, TP reaches maximum, then declines. This stage is important because businesses must find the right balance of inputs to maximize production without inefficiency. Why does diminishing returns happen? 1. Some factors remain fixed. Machines, land, or capital cannot be increased immediately. Too many workers may not have enough machines to work with. Some resources become scarce. Skilled labor, raw materials, or land may not always be available. Example: if a factory lacks skilled workers, adding more unskilled workers won't increase production much. 3. No perfect substitute for resources. Some inputs cannot be replaced easily. Example: if there is a shortage of skilled engineers, hiring more assistants won't maintain efficiency. Why is this law important? 1. It's universal, applies everywhere: agriculture, manufacturing, services. 2. Explains resource limits, shows why companies can't grow production forever without more resources. 3. Theory of rent. Ricardo's theory of rent is based on this law. Land is fixed, so extra labor has diminishing returns. 4. Theory of distribution. Marginal productivity theory states that as we keep adding inputs, their individual contribution decreases, affects wages, rent, etc. Industrial versus agricultural growth. Agriculture faces diminishing returns faster, while industries delay it through technology. Short trick to remember. Key points. Fixed, scarce, no substitute, universal, rent, industry. Word F ends like fusion, reminds you that limited resources reduce efficiency. F fixed factors remain, est scarce resources, and equals no perfect substitute. Universal law, rent theory, Ricardo. I industrial growth delayed. If you remember FSN Nuri fusion, you'll recall the law of diminishing returns easily in exams. Law of negative returns, simple explanation. At this stage, everything declines. Total product TP, marginal product MP, and average product AP. Adding more inputs reduces overall output. TP stops growing and starts declining. MP becomes negative, AP keeps decreasing. This stage is called negative returns because extra inputs cause inefficiency and reduce production. Why does negative returns happen? Too many workers, less work, overcrowding. If too many workers share limited machines or space, they get in each other's way and slow down work. Example, 10 chefs in a small kitchen will be less productive than 4 or 5. 2. Overuse of resources beyond optimum limit. Machines break down, materials get wasted, and efficiency drops. Example, a factory running 24/7 without maintenance will produce faulty products. Identifying the 3 stages with example, labor units, total product, marginal product. Stage, will 1, 2. 1, 2, 50 MP increases, 60. Stage 1, increasing returns. 2, 5, 110, 180. MP decreases from 40 to 0. Stage 2, diminishing returns. 5, 6, 180, 150. MP becomes negative of 30. Stage 3, negative returns. Now, a short trick to remember. Key points. Overcrowding, waste, negative, limit exceeded. Word equals own less, sounds like overcrowding, too many workers. W equals waste, inefficiency increases. N equals negative MP, equals limit exceeded. If you remember own less, it reminds you that negative returns, too much input leads to loss. Isoquants, simple explanation. What is an isoquant? An isoquant is a curve that shows different combinations of inputs, like labor and capital, that produce the same level of output. Key points. Isoquants equals equal output, different input combinations, also called isoproduct curve or production indifference curve, used by firms to find the best input mix. Definitions. Ferguson. An isoquant is a curve showing all possible combinations of inputs physically capable of producing a given level of output. Peterson. An isoquant curve may be defined as a curve showing the possible combinations of 2 variable factors that can be used to produce the same total output. Example, a factory can produce 100 units using 1 machine plus 12 workers, 2 machines, 8 workers, 3 machines, 5 workers. Since all combinations produce 100 units, they lie on the same isoquant curve. Havert isoquant table example, combination factor X, factor Y workers. Output, A, 1, 12, 100, B, 8, 200, C, 3, 100, D, 4, 3, E, 5, 2. Graph interpretation. When we plot these combinations, we get an isoquant curve IQ that shows all points where the same output is produced. Short trick to remember, word method. Key points. Same output, different inputs, indifference, combination. Same output equals optimal. Input mix. D to E, different. Input combinations. I equals indifference curve. C equals cost efficiency. If you remember So Dick, you'll recall that an isoquant, same output with different input combinations. Assumptions of isoquants, simple explanation. Isoquants are based on certain assumptions to make analysis easier. These assumptions help in understanding how different combinations of inputs produce the same output. 1. Only two inputs considered. Assumes only two factors of production, like labor and capital, for easy graphing. If there are more inputs like land, machinery, etc., it becomes complex. Example: a company can produce 100 units using 2 machines plus 5 workers, or 3 machines, 3 workers. 2 inputs are divisible. Factors of production can be used in different proportions, small or large quantities. Example: a bakery can use more flour and less sugar, or more sugar and less flour, but still bake the same number of cakes. 3. Technology is constant. No changes in production techniques while studying isoquants. If new technology is introduced, the isoquant changes. Example: a factory uses the same machines and tools, ensuring output remains comparable. Different input combinations give the same output. If conditions change, different input combinations may give different outputs. The goal is to find the most efficient combination that gives maximum output. Example: a farm can grow 100 kilograms of wheat using 2 workers and 1 tractor, or 5 workers and no tractor. Short trick to remember: word method. Key points: 2 inputs, divisibility, constant tech, different combinations. Word equal TDCD, like TDC Bank. T equals 2 inputs only. D equal divisibility of inputs. C equals constant technology. D equals different input combinations. Remember, TDCD, and you'll recall the 4 key assumptions of isoquants. Types of isoquants, simple explanation. Isoquants show different combinations of inputs that produce the same output. The shape of the isoquant depends on how easily one input can be replaced by another. 3 main types of isoquants. 1. Linear isoquants, perfect substitutes. Straight line. Inputs can fully replace each other without affecting output. Example: a farmer can produce 100 kilograms of wheat using only tractors, or only labor, or any mix of both. Graph, a straight line, because one input can be replaced by another easily. 2. Right angle isoquants, perfect complements, L shape. Inputs must be used together in fixed proportions, no substitution possible. Example: plastering a wall needs 2 bags of sand and 1 bag of cement. You can't replace cement with extra sand. Graph? An L shape, because increasing one input alone won't work. 3. Convex isoquants, imperfect substitutes, curved line. Inputs can be replaced, but not perfectly. Example: a cloth factory can use either more workers and fewer machines, or fewer workers and more machines, but not fully replace one with the other. Graph, a curved line, because substitution is possible, but not perfect. Short trick to remember: word method, key points, linear, right angle, convex word. Like LRC College, L equal linear isoquant, straight line, perfect substitute. R equal right angle isoquant, L shape, no substitute, only fixed proportions. C, convex isoquant, curved partial substitutes. Remember LRC and you'll recall all 3 types of isoquants easily. Simple explanation. Isoquant curves have certain properties that help understand how inputs like labor and capital are used in production. Key properties of isoquants. 1. Isoquants are negatively sloped, downward sloping. If one input, like labor, decreases, the other, like capital, must increase to maintain the same output. Example: if a company hires fewer workers, it must use more machines to keep production steady. 2. Higher isoquants represent higher output. The more resources, labor, and capital used, the more output is produced. Example: a bakery using 10 workers plus 2 ovens will produce more than a bakery using 5 workers, 1 oven. Graph. Higher curves indicate more output. 3. No 2 isoquants intersect or touch. Each isoquant represents a different level of output, so they never cross. Example: a curve for 100 units cannot touch a curve for 200 units, because they represent different outputs. 4. Isoquants are convex to the origin, curved inward. Substituting one input for another becomes harder over time, diminishing returns. Example: if a company replaces machines with workers, at first, productivity may stay the same. But after a point, adding more workers without machines reduces efficiency. Short trick to remember. Word method. Key points: negative slope, higher output, no intersection, convex shape. Word equals NHNC. Think of NHNC college. N equals negative slope, input 1, like input 2. H equals higher isoquant equals more output. N equals no intersection. Isoquants never touch. C equals convex shape, curved inward due to substitution limits. Just remember NHNC, and you can recall all 4 properties easily. Significance of isoquant curve in cost analysis. Simple explanation. Isoquant curves help businesses make smart production decisions by adjusting inputs efficiently to reduce costs. Key points. Helps adjust inputs for a fixed output. A firm can decide how much labor and capital to use to produce a specific output. Example, a car company can choose more workers plus fewer robots, or fewer workers, more robots to produce 100 cars. 2. Finds the lowest cost combination. Isoquant curves help firms select the cheapest mix of inputs for the same production level. Example, if 1 worker plus 2 machines costs $10,000, but 2 workers plus 1 machine costs $8,000, the firm chooses the cheaper option. 3. Aids decision-making for different budgets. Firms with different budgets can use isoquant curves to choose the best production method. Example, a small business may use more labor, cheaper, while a large firm may use more machines, efficient but costly. Short trick to remember. Key points. Adjust inputs, lowest cost, budget decision. Word of ALB equals adjust, lowest. A equal adjust inputs, choose the right mix of labor and capital. L equal lowest cost, find the cheapest way to produce. B, budget decision, helps firms decide based on money available. Just remember ALB, and you can recall the significance of isoquant curves easily. Expansion path, simple explanation. When a firm grows, it needs to increase production. The expansion path helps decide the best mix of inputs, like labor and capital, to produce more at the lowest cost. Key points. 1. Expansion path equals best way to grow efficiently. It shows how to increase production step by step while keeping costs low. Example, a small bakery increasing both machines and workers in the right proportion to produce more cakes. 2. Long-term expansion path. All inputs can change. In the long run, both labor and capital can be increased in equal proportion. The firm moves from one best production point to another in a straight line. Example, a car factory buying more machines plus hiring more workers to expand smoothly. 3. Short-term expansion path. One input is fixed. In the short run, one input, like machines, remains fixed, and only the other, like labor, can change. The firm adjusts output within limits, but full expansion isn't possible. Example, a textile mill adding more workers but keeping the same number of machines for now. Short trick to remember. Key points. Best way, long term, short term, or BLS. Think of BLS equals best, long, short. B equals best way to grow. Expansion path finds the cheapest way to increase production. L equals long-term expansion. Both labor and capital increase in the right ratio. S equals short-term expansion. Only one factor changes, other is fixed. Just remember BLS, and you can recall expansion paths easily. ISO cost equal cost line, simple explanation. An ISO cost line shows different combinations of labor L and capital K that a firm can buy within a fixed budget. Think of it as a shopping budget. If you have digorwilly 100,000, you can spend it all on labor, or all on capital, or find a mix of both. 1 ISO cost line equals budget limit. It shows all possible combinations of inputs, L and K, within a given budget. Example, a factory can either hire 200 workers or buy 10 machines with 100,000s. The line AB represents all possible choices. 2. Slope of ISO cost line. The slope equals price ratio of labor to capital, DKDL. If labor becomes cheaper, the company can hire more workers. ISO cost line shifts right. If capital becomes cheaper, the firm can buy more machines. 3. Movement of ISO cost line. If the company gets more money, it can buy more inputs. ISO cost line shifts outward. If the prices of inputs change, the slope changes, but line position may remain the same. Short trick to remember, word method. Key points. Budget, slope, movement. Word equals BSM, budget, slope, movement. B equal budget limit, shows all combinations within a fixed budget. Slope depends on input prices. M movement shifts when budget increases or prices change. Just remember BSM, and you can easily recall ISO cost line. Difference between isoquant curves and indifference curves. Isoquant curves and indifference curves look similar because both show different combinations of two things. However, their meaning and use are completely different. Key differences: isoquant curve, indifference curve. Definition shows different input combinations that give the same level of output. Shows different product combinations that give the same level of satisfaction. Related to production, supply side, consumption, demeasurable? Yes. Output is a physical quantity. No, satisfaction utility is subjective. Easy example to understand. Isoquant curve production example. A factory can produce 1,000 chairs by using option 1, 5 workers plus 3 machines. Option 2, 3 workers plus 5 machines. Both options give the same output, so they lie on the same isoquant curve. Indifference curve, consumer example. A person has 50 to spend on food. Option 1, 2 pizzas plus 1 burger. Option 2, 1 pizza plus 2 burgers. Both options give equal satisfaction, so they lie on the same indifference curve. Short trick to remember, word method. Key points. Production, demand, measurable, word PDM. Think PDM equal production, demand, measurable. Production, isoquant curve, D equals demand, indifference curve. M equals measurable. Only isoquant curve is measurable. Just remember PDM, and you can easily recall the difference. Isoquant map, simple explanation. An isoquant map is a set of multiple isoquant curves showing different levels of output based on different input combinations. Key points to remember. 1. Isoquant map equals multiple isoquant curves. It shows different combinations of inputs, labor and capital, to produce different levels of output. 2. Closer to origin, lower output. Near the origin, lower production. Far from origin, higher production. 3. Each isoquant represents a specific output level. IU, lowest output. IQ2, medium output, highest output. Easy example. Imagine a bakery making cakes. Low output uses 2 bakers plus 1 oven, produces 100 cakes. IQ, medium output, uses 3 bakers plus 2 ovens, produces 200 cakes. Q for high output, uses 4 bakers, 3 ovens, produces 300 cakes. Each combination increases production, forming an isoquant map. Short trick to remember. Key points. Multiple, output, distance. Word equals mod. Think multiple outputs distance. M equals multiple isoquant equals output levels increase. Distance from origin. Just remember mod, and you can easily recall the concept. Marginal rate of technical substitution, RTS, simple explanation. MRTS shows how much of one input, capital, needs to be reduced when another input, labor, is increased, while keeping the output constant. Key points to remember. MRTS equals how inputs can replace each other. If a company adds 1 more worker, it can reduce some machines while still producing the same output. Example, if labor increases, capital decreases to maintain the output. Diminishing MRTS. At first, replacing capital with labor is easy. Later, it becomes harder. You can't replace machines with unlimited workers. Example, a bakery can replace some machines with extra bakers, but after a point, more bakers won't help without machines. Formula for MRTS. MRTS equals change in capital, change in labor. Shows how much capital is reduced when labor is added. For graph of MRTS, isoquant curve, MRTS is represented by the slope of an isoquant curve, downward sloping. The more we move right, the harder it gets to substitute capital with labor. Exceptions to diminishing MRTS? Perfect substitutes. If two inputs fully replace each other, e.g. pens and pencils, MRTS is constant, 1-to-1. Perfect complements. If two inputs must be used together, e.g. car and fuel, MRTS does not apply. Easy example. Imagine a restaurant. Scenario 1. If one chef leaves, another chef can substitute for them. Scenario 2. If all chefs are gone, adding more waiters won't help. Short trick to remember. Word method. Key points. Substitution, output, diminishing, exceptions. Think SOT substitution, output, diminishing, exceptions. SIPs. S equals substitution of input, so output constants, and D equals diminishing over time. Out E, exceptions exist. Just remember ISOTA and you can recall MRTS easily. Optimal input choice. Cost minimization versus output maximization. This concept explains how a producer selects the best combination of inputs, labor and capital, to either minimize costs for a given output or maximize output for a given cost. Key points to remember. 1. What is optimal input combination? It is the best mix of labor and capital that helps a firm maximize output at minimum cost, also called producer's equilibrium or least cost factor combination. 2. Two ways to optimize inputs. Minimize cost. Find the cheapest way to produce a set amount of output. Maximize output. Get the highest output possible with a fixed budget. 3. How to find the best combination. Overlay the isoquant map output levels on the isocost line, cost levels. The best point is where they touch tangent. This means both inputs contribute equally to production based on their cost. 4. Formula for least cost combination. Marginal physical product, MPP per dollar spent on labor, it's MPP per dollar spent on capital. If not equal, the producer should adjust input usage to optimize cost. Real-world example. A factory can use either workers, labor, or machines, capital, to make 100 chairs. If labor is cheap, they hire more workers. If machines are efficient, they reduce workers and buy more machines. The goal is to balance cost and output effectively. Short trick to remember. Word method. Key points. Cost, output, balance, efficiency. Word equals COB, B. Think. COB, cost, output, balance, efficiency. C, cost minimization, OAKS, output maximization. B, balance of inputs. E, efficiency and production. Just remember COB, and you can recall the concept easily. Optimizing two inputs. Cost minimization versus output maximization. This concept explains how a firm chooses the best combination of labor L and capital K to either minimize costs while maintaining output or maximize output within a fixed budget. Key points to remember. 1. What is input optimization? It is the process of selecting the right mix of labor L and capital K to achieve the best output with minimum cost. A firm is in equilibrium when it reaches the least cost combination for production. 2. Formula for production function. Q equals FLK. Output Q depends on labor L and capital K. 3. Marginal rate of technical substitution, MRTS. MRTS equals MPL MPK, measures how much capital can be reduced if labor is increased while keeping output the same. Firms adjust inputs until MRTS equals the ratio of their prices. 4. Cost minimization condition. The firm minimizes cost when MPL lie W equals MPKR. Marginal productivity per ray spent on labor equals marginal productivity per ray spent on capital. The isocost line budget constraint should be tangent to the isoquant curve output level. Output maximization condition. If the firm wants to maximize output with a fixed budget, it adjusts inputs to reach the highest possible isoquant that its isocost line allows. The same tangency condition applies, ensuring efficiency. 6. Graphical representation, isoquant and isocost. Isoquant curve equals different combinations of inputs that produce the same output. Isocost line equals different combinations of inputs that cost the same. The optimal point is where the isoquant touches the isocost line, point M in the diagram. Real-world example. A factory wants to produce 500 chairs. It can hire more workers and use fewer machines, use more machines and hire fewer workers. The firm chooses the least expensive mix that still makes 500 chairs. Short trick to remember, word method. Key points. Cost, output, labor, capital, efficiency. Word equals COLS. Think COLS, cost, output, labor, capital, efficiency. C equals output maximization. L, labor, capital optimization, equal combination of inputs. E, efficiency in production. Just remember, and you can recall the concept easily of single output. This concept explains how a firm can maximize its output while maintaining the same cost. Key points to remember. 1. What is single output optimization? A firm wants to maximize its output, Q, while keeping its cost fixed. The prices of labor, L, and capital K, play a key role in this decision. 2. Equilibrium condition. The firm is in equilibrium when it reaches the maximum output with a given cost. This happens where the isoquant curve output level is tangent to the isocost line budget limit. At this point, WR equals MPL, MPK equals MRTS, marginal rate of technical substitution. 3. Graphical representation. Figure 3.2 isoquant curve output levels shows different input combinations that produce the same output. Isocost line, budget constraint, shows different combinations of labor and capital that cost the same. Optimal point P. At point P, the isoquant curve for 200 units is tangent to the isocost line CL. This is the best combination of labor, ON, and capital, OM, for the firm. Points E and F are not optimal because they produce only 100 units of output. Important condition for maximization. The isoquant curve must be convex to the origin at the point of tangency. This ensures a stable equilibrium for the firm. 5. Real-world example. A bakery has a fixed budget but wants to bake the maximum number of cakes. It can hire more workers, L, and use fewer machines, K, use more machines, K, and hire fewer workers, L. The bakery finds the best mix at point P, where it produces the highest number of cakes within the budget. Short trick to remember, word method. Key points. Profit, output, labor, capital, equilibrium. Word equals pulse. Think PULSE, profit, output, labor, capital, equilibrium. P, profit maximization. O equals output maximization. L, labor and capital balance. C equals cost consideration. E equals equilibrium condition. Just remember pulse, and you can recall the concept easily. Ridgelines in production. This concept helps us understand the efficient and inefficient use of inputs in production. Key points to remember. 1. What are ridgelines? Ridgelines separate the useful economic production area from the inefficient areas. Inside the ridgelines, inputs can be substituted. Outside the ridgelines, inputs cannot be substituted. 2. Understanding isoquants and ridgelines. Isoquants show different combinations of inputs that produce the same output. Ridgelines mark the limits of meaningful input substitution. Beyond these lines, adding more inputs does not increase output efficiently. 3. Why ridgelines are important. Inside the ridgelines, efficient production. Outside the ridgelines, wasted resources. Higher inputs, same output. 4. Key observations in the graph. Upper ridgeline MPK equals 0. More capital does not increase output. Lower ridgeline MPL more labor does not increase output. The best production area is inside these ridgelines, called the economic region. 5. Real-world example. Imagine a restaurant kitchen. Efficient zone inside ridgelines, proper balance of chefs, labor, and ovens, capital. Inefficient zone outside ridgelines, too many chefs but only one oven, lower ridgeline. Too many ovens but one chef, upper ridgeline. Short trick to remember, word method. Key points. Ridge, isoquant, substitution, economic region. Word equals rise. Think rise, ridge, isoquant, substitution, economic. R equals ridgelines, isoquants, and input balance. S equals substitution limits. E equals economic region. Just remember rise, and you can recall the concept easily. Elasticity of substitution, EOS. This concept tells us how easily one input or good can replace another in production or consumption. Key points to remember. 1. What is elasticity of substitution? It measures how easily two inputs or goods can replace each other. Example, coffee and tea. If tea prices rise, will people switch to coffee? 2. How is it calculated? It is the percentage change in input ratio X for Y divided by the percentage change in marginal rate of substitution, MRS. Formula, ES equals frac text, change in X or Y, text change in MRS. 3. Types of elasticity of substitution, perfect substitutes, straight line indifference curve, e.g. Pepsi and Coke. 0, perfect complements, L-shaped indifference curve, e.g. car and wheels. Between 0 and clammy, some substitution possible, e.g. tea and coffee. In production versus consumption. In production, how labor and capital replace each other. In consumption, how goods replace each other based on price changes. Real-world example, machines and workers. If wages rise, companies may use more machines, high elasticity. Fuel options. If petrol prices increase, people may shift to electric vehicles, medium elasticity. Short trick to remember. Key points. Elasticity inputs substitution efficiency. Word equals E-Inc E elasticity input substitution efficiency. E equals elasticity, how much substitution is possible. I equals inputs, labor, capital, goods. S equals substitutes, can one replace another? Efficiency, best way to use inputs. Just remember, and you can recall the concept easily. Law of returns to scale. This law explains how output changes when all inputs, labor, capital, land, change in the same proportion in the long run. 1. What is returns to scale? It describes the relationship between input and output in the long run. Example, a factory doubles machines and workers. Does output double, more than double, or less than double? 2 definitions by economists, Roger Miller. Relationship between change in output and proportionate change in inputs. Koutsogiannis, output changes when all factors change in the same proportion. Lehafsky, a long-run concept showing how total output changes when all inputs change. 3. Real-world example. A bakery increases flour, workers, and ovens by 2 times. If production increases 2 times, constant returns to scale. If production increases more than 2 times, increasing returns to scale. If production increases less than 2 times, decreasing returns to scale. Short trick to remember, word method. Key points, long run, inputs proportion output. Word equals LIPO. Think LIPO, long run inputs proportion output equals long run, time period. I equals inputs, all factors change. Proportion, inputs change equally. O equal output, how much it changes. Just remember LIPO, and you can recall the concept easily. Assumptions of returns to scale. These are the conditions that must be true for the law of returns to scale to apply. Key points to remember. 1. All inputs change except enterprise. Inputs like labor, land, capital can increase or decrease. The enterprise, business owner management, stays the same. 2. Workers perform accurately. Employees use machines and tools efficiently without mistakes. No change in technology. Machines and methods remain the same. No new tech is introduced. 4. Perfect competition exists. Many firms, no one controls the market, and prices are determined by demand and supply. 5. Output is measured in quantity. Production is counted in physical units like tons, liters, or pieces, not money value. Short trick to remember, word method. Key points, inputs, workers, tech, competition. Output word equals IWTCO, think I work to count output. I inputs change, except enterprise. W equals workers perform well. T technology is constant. C equal competition is perfect. Output is measurable. Just remember IWTCO, and you can recall the assumptions easily. Types of returns to scale. Returns to scale explain how output changes when all inputs, labor, capital, land, are increased in the same proportion in the long run. There are 3 types of returns to scale. IRS. Output increases more than the increase in inputs. Example, if you double 2x labor and machines, output becomes 3 times 3x. Why does this happen? Specialization. Workers focus on one task and work efficiently. Better use of resources. Machines and labor used smartly. Example, a bakery increases flour and workers by 10% but produces 20% more cakes. 2. Constant returns to scale. Output increases in the same proportion as inputs. Example, if inputs double 2x, output also doubles 2x. Why does this happen? The firm operates at optimal efficiency, no extra gains from expansion. Example, a factory doubles machines and workers, and production also doubles. 3. Diminishing returns to scale, DRS. Output increases less than the increase in inputs. Example, if inputs double 2x, output increases only 1.5 times. Why does this happen? Inefficiencies like overcrowding of workers, mismanagement, and wastage. Example, a restaurant hires too many chefs, but space in the kitchen is limited, so production slows down. Short trick to remember, word method, key points. Increasing, constant, diminishing. Word equal ICD, I can develop. I equal increasing returns, output grows fast. C equal constant returns, output grows equally. D, diminishing returns, output slows down. Just remember ICD, and you can recall all 3 types of returns to scale easily. Difference between returns to scale and returns to scope. Both concepts talk about cost advantages in production, but they focus on different aspects. Factor, returns to scale. Returns to scope. Meaning, producing more of the same product to reduce cost. Producing multiple different products efficiently to reduce cost. Focus, quantity, high volume of one product. Different products. Cost reduction, average cost decreases as production increases. Cost savings by producing similar products together. Time period, traditional concept known for a long time. Modern business strategy. Process, uses the most efficient process for mass production. Uses shared resources and technology to make different products efficiently. Example, a car factory making more cars to reduce cost per car. A bakery making cakes and cookies together using the same ingredients and ovens. Short trick to remember, word method. Key points. Scale, same product. Scope, different products. Word equals SSS. Think, same scale, scope separate. So scale, same product, more quantity. S equals scope, separate products, more variety. Just remember SSS, and you can easily recall the difference between law of variable proportions and laws of returns to scale. Both concepts are related to production, but focus on different time frames and input behavior. Factor, law of variable proportions, short run. Laws of returns to scale, long run. Nature of inputs. Some inputs are fixed, others vary. All inputs are variable. Time period. Short run concept, long run concept. Homogeneity, uniformity of production, non-homogeneous, inputs not proportional. Homogeneous, inputs proportional. Increasing returns, non-linear, output does not increase proportionally. Non-linear, similar pattern. Constant returns, linear, fixed proportion but short-term. Linear, fixed proportion but long-term. Diminishing returns, non-linear, due to fixed inputs. Non-linear, due to capacity limits. Simple explanation. Law of variable proportions, short run. Some inputs, like land, cannot be changed. Output changes based on how other inputs, labor, capital, are adjusted. Example, adding more workers to a small shop may increase output initially, but will later lead to crowding and inefficiency. Laws of returns to scale, long run. All inputs can be increased or decreased. The firm expands production by scaling up everything together. Example, a company doubles its factory size, machines, and workers, leading to higher overall production. Short trick to remember. Key points. Variable proportions, VP, short run, some inputs fixed. Returns to scale, RS, long run, all inputs variable. Word equals VRS, think variable run scale. V equal variable proportions, short run, some inputs fixed. R equal returns, long run, all inputs variable. S equals scale, large scale expansion. Just remember S and you can easily recall the difference. Economies and diseconomies of scale. This concept explains how a firm's cost of production changes as it expands its operations in the long run. 1. Economies of scale, cost as output. When a firm produces more, its average cost per unit decreases. This happens because better specialization, workers and machines become efficient. Bulk purchasing, buying in bulk, reduces cost per unit. Efficient use of machinery, large-scale production reduces waste. Example, a car company producing 1,000 cars per month has lower costs per car than a company producing just 100 cars per month. Diseconomies of scale, cost as output too much. After a certain point, producing more leads to higher costs per unit. This happens because management becomes complex, harder to control a big company. Communication problems, more employees, more confusion. Resource limitations, too much production can lead to inefficiencies. Example, a restaurant with too many chefs in the kitchen might struggle to manage orders efficiently, leading to delays and wastage. #3, long-run average total cost, LRITC curve. The LRITC curve is U-shaped. Left side, downward slope, economies of scale, cost. Middle, constant returns to scale, cost stable. Right side, upward slope, diseconomies of scale. Short trick to remember. Key points, economies of scale, cost down, diseconomies of scale, D, cost up. Word equals EDU. Think education about scale. E equal economies of scale, cost down, efficiency. D, diseconomies of scale, cost up, inefficiency. U, U-shaped curve. Just remember, and you can easily recall the concept. Economies of scale, simple explanation. Economies of scale mean that as a company produces more, its cost per unit decreases. This happens because fixed costs, like rent, machinery, are spread over more products, making each item cheaper to produce. 1. Meaning of economies of scale. Big companies produce goods at a lower cost per unit than small companies. When production increases, efficiency increases, cost decreases. Example, a small bakery makes 10 cakes a day. It buys ingredients in small quantities, making each cake cost 100. A large bakery makes 1,000 cakes a day. It buys ingredients in bulk, reducing the cost per cake to 70. 2. Definitions of economies of scale. Porter, declines in the unit's cost of production. Reduction in average unit costs due to an increase in scale of output. Spencer, curvilinear relationship between average cost and number of units produced. Why economies of scale matter. Lower costs, higher profits. Big companies can reach more customers. More production, more efficiency. Short trick to remember. Keywords, efficiency, C, cost, production. Word ECP, economies cut prices, EE equal economies of scale efficiency, cost reduction, P equals production increase. Just remember ECP and you will never forget the concept. Diseconomies of scale, simple explanation. Diseconomies of scale occur when a company grows too large, causing higher costs instead of cost savings. This happens due to management issues, inefficiency, or coordination problems. Meaning of diseconomies of scale. When production increases too much, cost per unit starts increasing instead of decreasing. It cancels out the benefits of economies of scale. Example, a company expands too fast, hiring too many workers, increasing wastage and mismanagement. A small restaurant expanding into a big chain might struggle with quality control, increasing food wastage and costs. 2. Why diseconomies of scale happen. Too many workers, hard to manage. Complex processes, more mistakes. Poor communication, delays and confusion. 3. How to avoid diseconomies of scale. Keep production at an optimal level, not too large. Use small efficient production units instead of one large unit. Improve management and coordination. Short trick to remember. Keywords: I, inefficiency, C, coordination issues, hate higher costs. Word ICH, inefficiency, creates high costs. Inefficiency, C, coordination problems, H, higher costs. Just remember ICH, and you will never forget diseconomies of scale. Types of economies and diseconomies of scale. Simple explanation. When a business grows, it can either reduce costs, economies of scale, or increase costs, diseconomies of scale. These can be internal, inside the company, or external, outside the company. Internal economies of scale, cost saving inside the company, happens when a company grows and reduces costs because of better technology, faster production, bulk buying, lower material costs, specialized workers, increased efficiency. Example: a car company buys raw materials in bulk, reducing cost per unit. Internal diseconomies of scale, cost increase inside the company, happens when a company grows too much and costs start increasing due to poor communication, mismanagement, too many workers, lower productivity. Overloaded machines, frequent breakdowns. Example: a large restaurant struggles with slow service and food wastage due to mismanagement. 3. External economies, cost saving from outside factors, happens when businesses benefit from industry growth, such as better infrastructure, faster transportation, government support, tax benefits, more suppliers, lower material prices. Example: IT companies in Bangalore benefit from tech parks and skilled workers. 4. External diseconomies of scale, cost increase from outside factors, happens when industry expansion increases costs due to high competition, expensive materials, traffic congestion, delayed deliveries, more pollution, higher compliance costs. Example: too many factories in an area cause pollution and government fines, increasing costs. Short trick to remember. Keywords: I, internal economies, D, internal diseconomies, E, external economies. Word equals IDED, internal external diseconomies, economies difference. Just remember IDE and you can easily recall the 4 types. Internal economies and diseconomies of scale, simple explanation. When a company grows, it initially enjoys cost savings, economies of scale, but after a certain point, it starts facing higher costs, diseconomies of scale. There are 5 types of internal economies and diseconomies. Technical, managerial. 3. Commercial or financial. 5. Risk-bearing. 1. Technical economies and diseconomies. Production-related. Economies. Big firms use better technology and machines to produce more at a lower cost per unit. Diseconomies. If a company expands too much, managing large machines and production becomes inefficient. Example: a car factory uses advanced robots to produce more cars cheaply, but if it expands too much, machines break down often, increasing costs. 2. Managerial economies and diseconomies, management-related. Economies. With growth, firms hire specialized managers, e.g. sales, finance, more efficiency. Diseconomies. Too many managers lead to poor coordination, bureaucracy, and slow decisions. Example: a company divides sales into domestic and export teams, increasing efficiency, but if it creates too many subdivisions, communication issues arise. 3. Commercial economies and diseconomies, buying and selling related. Economies. Large firms buy raw materials in bulk at lower prices and save on advertising costs per unit. Diseconomies. After a certain size, marketing and advertising costs rise disproportionately. Example: a supermarket buys rice in bulk at a discount, reducing costs, but if it opens too many stores, marketing expenses increase heavily. 4. Financial economies and diseconomies, funding related. Economies. Big firms get loans at lower interest rates and can raise money easily. Diseconomies. If they overborrow, financial costs rise, and they depend too much on external funds. Example, a large company gets cheaper bank loans, but if it keeps borrowing excessively, interest costs rise. 5. Risk-bearing economies and diseconomies handling risk. Economies. Large firms diversify products, reducing business risk. Diseconomies. Too much diversification can increase complexity and losses. Example, a company sells electronics and clothing, reducing dependence on one market. But if it expands into unrelated businesses, risks increase. Short trick to remember. Take the first letter of each type. T, technical. M, managerial. C, commercial. F, financial. R, risk-bearing word, equals TMCFR, think more, costs fall rapidly. Just remember TMFR, and you can easily recall the 5 types. External economies and diseconomies of scale. Simple explanation. When an entire industry grows, all firms in that industry benefit economies of scale. But after a certain point, they start facing problems, diseconomies of scale. These effects come from outside the firm, so they are called external economies and diseconomies. There are 5 types of external economies and diseconomies. 1. Cheaper raw materials and capital equipment. 2. Technological improvements. 3. Skilled labor development. 4. Growth of supporting ancillary industries. 5. Better transport and marketing. 1. Cheaper raw materials and capital equipment. Economies. As the industry grows, firms find cheaper sources of raw materials and machinery, reducing production costs. Diseconomies. If too many firms compete for the same materials, prices increase. Example. When many smartphone companies grow, suppliers reduce the cost of components. But if demand is too high, chip prices rise. Technological improvements. Economies. Industry growth leads to new technology and better machines, making production faster and cheaper. Diseconomies. Some firms fail to adopt new technology and struggle to compete. Example. In the automobile industry, new robots improve efficiency, but small car makers who can't afford robots face higher costs. 3. Skilled labor development. Economies. Growth in an industry attracts more skilled workers, increasing productivity. Diseconomies. If demand for skilled workers is too high, their wages rise, increasing costs. Example, IT companies attract skilled programmers, but when demand increases, salaries become very high, raising costs. 4. Growth of supporting ancillary industries. Economies. As an industry grows, supporting industries, raw material suppliers, tool makers also grow, making resources cheaper. Diseconomies. If too many firms depend on the same suppliers, competition raises prices. Example, car companies benefit from specialized spare part manufacturers, but if too many firms buy parts, costs rise. 5. Better transport and marketing. Economies. Industry expansion improves transportation and communication, reducing costs. Diseconomies. Too many firms in one area cause traffic congestion, pollution, and higher transport costs. Example, growth of textile factories improves transport in a city, but too many factories increase pollution and logistics costs. Short trick to remember. Take the first letter of each type. C, cheaper raw materials. T, technology. S, skilled labor. A, ancillary industries. T, transport and marketing. Word equals CTSAT, cost-saving tech and transport. Just remember CTSAT, and you can easily recall the 5 types. 3.6.1 Short answer type questions. 1. What is the concept and meaning of production? 2. Define production function and state its assumptions. 3. What are the various laws of production? 4. What are the assumptions of the law of variable proportions? 5. Explain the law of diminishing marginal productivity. 6. What are the types of isoquants? 7. How do indifference curves differ from isoquant curves? 8. What is an iso-cost line? Explain. 9. What is an isoquant map? 10. Write a short note on MRTS, marginal rate of technical substitution. 11. What are ridge lines? Explain in detail. 12. What is the difference between returns to scale and returns to scope? 13. How does the law of variable proportions differ from the laws of return? 14. What are economies and diseconomies of scale? Part 3.62. Long answer type questions. 1. Define production. What are the factors of production? 2. Explain the importance, types, and estimation of the production function. 3. What is the law of variable proportions? Draw a table and show the relationship between total, marginal, and average physical products. Also, explain the various laws of returns. 4. Describe the 3 stages of the law of variable proportions. 5. What are isoquants? Discuss their assumptions, properties, and significance. 6. What is the optimum combination of inputs? Explain cost minimization versus output maximization. 7. Explain the elasticity of substitution in detail. 8. Define the law of returns to scale. State its assumptions and types. 9. What are the various kinds of economies and diseconomies of scale? Illustrate with examples. Here are the numerical questions along with their answers. 3.6. Numerical questions. 1. Calculate the average product and the marginal product of a factor from the following table. Factor employed, total product, TP, in 0, 0, 1, 5, 2, 12, 3, 18, 4, 20, 35, 6, 48. Our solution. Average product AP equals TP is factor employed, marginal product MP equal change in TP, change in factor employed. Factor employed TP, AP, TP factor, MP delta TP with a factor 0, 0, 1, 5, 5.0, 5, 2, 12, 6.0, 7, 3, 18, 6.0, 6, 4, 20, 5.0, 2, 5, 35, 7.0, 15, 6, 48, 8, 13. 2. Identify the different phases in the law of variable proportions from the following table. Variable input, marginal product, 120, 225, 324, 10, 506, minus 10. Solution. Identifying phases of the law of variable proportions. Variable input, phases, stages. Stage 1, increasing returns, MP rising. 2, 25, stage 1, increasing returns 3, 20. Stage 2, diminishing returns, MP falling, 4, 10. Stage 2, diminishing returns 5. Stage 2, diminishing returns 6, 9 is 10. Stage 3, negative return, complete the table given below. Unit of labor, total product, TP, marginal product, average product AP, average product AP 0, 0, 0, 9s, 1, 10, 10, 10, 2, 21, 11, 10.5, 3, 33, 12, 11, 4, 44, 11, 5, 52, 8, 10.4, 6, 60, 8, 10. Identify the various phases of the law of variable proportions in the change in total product. Also, find AP and MP. Unit of labor, total product, TP, 1, 10, 2, 22, 3, 30, 4, 36, 5, 36, 6, 30. Formulas AP equal TP y labor input. MP equals change in TP, change in labor input. Unit of labor, TP AP equal TP labor, MP equal delta TP del labor. Phases, stages, formulas. 1, 1, 10, 10.0, 10. Stage 1, increasing returns. 2, 22, 11.0, 12. Stage 1, increasing returns 3, 30, 10.0. 8, stage 2, diminishing returns. 4, 36, 9.0, 6. Diminish 6, 7.2, 0. Stage turns 6, HD 5.0, minus 6. Negative returns. This covers all the numerical questions with their step-by-step solutions. Let me know if you need any modifications.